Welcome to today's Ascendo Reliability webinar event or sequence or whatever we call it. I'm going to talk about, you just shipped a product and now what? I do vaguely remember years and years ago as I was working with Hewlett Packard, and I was working with a program that was I don't know, it was probably 9 months away from shipping. So I got to work on it and work with the engineering team and with quality and a whole bunch of other people on it. And we got to the point where it was in production and it was stocking shelves, and then it was launch day basically. And I asked one of my coworkers who'd been there for a long time and gone through many product launches. I said, now what? And he says, well, now we wait to figure out what we didn't catch or didn't fix or didn't understand. We just wait. And he goes, yep. In the meantime, we can get ready to work on the next project, which is going to be started up real shortly. So there was no lack of things to do. We weren't all just sitting around in our offices, twiddling our thumbs. Yet it was one of those things that was in this old hands experience, was that once you launch a product, then you find out whether it really works or not. And I always wondered about that. And I think it propelled me even deeper into reliability. But today I'm going to talk about a particular, I don't know, it was a lesson learned, or I ran into an organization that did this, and it worked exceedingly well. And then over time, I was able to implement this process called the Delta phase or Delta project in other organizations. They obviously then called it something else because everybody seems to want to name their own things, and in high volume and low volume and so on. So I'm going to explain some of the nuances and details of what I've seen has made the difference to whether it works or not. And so you can hopefully walk away with enough information to implement it on your own. And it's, I find, amazingly valuable and something that we should all plan on doing with each of our products. So at some point in our programs, the program manager or the management team or somebody says, you need to stop fiddling with this and ship it and get it out there, send it to the customers. Let's start making some revenue, and I've run into plenty, and I'm sure you have too, of engineers that, oh, there's more to do. It's not quite done yet. I have to fix this. I have to update that, whatever. And at some point, the design gets locked down, and then we start manufacturing it and we ship it. And so launch day typically arrives for vast majority of programs we work on, and it should be anticipated that we are going to actually start releasing these products out into the wild. Now, what happens though is, depending on your product and your type of system and technology and so on, you will probably get some returns. And they, unfortunately, for some of us, experience them back and within the week. Or I ran into one client years and years ago. They called me because they shipped 70,000 units, and in 2 weeks, 50,000 came back. And so they said, what did we miss? What did we do wrong? And I bit my tongue and said, well, you should have called me earlier in that other program, but I didn't. And so we worked out what the issue was and what some of the systemic things they were doing was. But hopefully you're not in that case where vast majority of your products come back within weeks. On the other hand, another team I worked with, they hired me to become basically their reliability engineer. It wasn't full time, but it was a couple days a week and lots of training. We went and did a bunch of stuff with them and worked through and developing their design for reliability program, making lots and lots of recommendations and decisions, setting up different ways that they can approach developing a reliable product, and got that implemented. And then they got to the launch period of time, and it was into manufacturing, and they had a pretty good handle on that part of it. So they were off and running. I didn't hear from them for about 3-4 months. And they called me back and says, we want you to come back and help us on this new project we're working on. And so I flew out there and chatted with them, and I asked them, so how did that project XYZ we're working, how'd that go? Because you told me in the past that within a week or within a month, you would have plenty of information about field failures. And they all kind of looked sheepish at each other, and nobody really knew what to say. And I was like, oh, was it that bad? Which I doubted they would have called me back to work on another program if it was that bad. And he says, no, after 6 weeks, we actually called some of our known customers to see how it was going, because it either was so bad they weren't even going to talk to us again, or it was so good that they didn't have to. They were happily using our products and going about their business. And so their first customer or field failure was 6 months later, the first one. Whereas the product before it was within a week, and many within the first month. And so they were very delighted at the change in their fortune of creating a product that actually works in the field. Yet, I don't know a single product that goes out that you don't hear some feedback one way or the other. So I'm going to assume that you're making a product that goes out and you get returns at some point or another. It might be some occasionally, or it might be a whole slew, or it might be some variation of all of that kind of stuff. We get product returns or field failure reports, field failures. Now, it is to be expected. We set up warranties, we set up, field service type things, we set up repair centers in some cases, we do all kinds of things to deal with the field failures. What I'm going to talk about today, this Delta phase, is a novel take on what to really do to really drive down the number of field failures, help your team learn an amazing amount of information about how your customers actually use your product. And then also, it had all kinds of benefits. We'll get into that a bit later. But first, how do you deal with field failures? And the chat window is open and the Q&A window is open. Let's make the assumption that you do get field failures or customer complaints. How do you deal with those? What do you do? So this gives me a chance to take a sip of tea. But what's your approach? Failure analysis and root cause corrective action, I think. Is that right, Mahindra? Max, about to launch. This is our first one. Don't know enough yet. All right. Well, good luck, Max. Hopefully it's not too late that you can implement some of this stuff here. Thanks, Mahindra. All right. I know there's a few more folks out there. How do you deal with field failures or customer complaints? Failure analysis is a common technique, no doubt about that. Yeah, pay the warranties out. Yeah, it's part of the deal. Much is information from the customer, and get that to a dedicated team to understand root cause and work towards solutions. Okay. All right. Try to replicate the failure mode. All right. Good. Yeah, those are all reasonable, good things to do, and fit in part what I'm going to be talking about. So hopefully you'll see a bit of a difference. At least none of you mentioned the most common one. Let me see if I can get my screen to go here. The most common approach is basically blame somebody else. Unless it's a safety or a regulatory issue that you chance really losing the market, or you're being pulled from the shelves, or some other major issue. A good number, not all, but thanks, is we get complaints or problems back from the field And it's not unexpected. That's why we set up repair centers and call centers and warranty. And it is actually to be expected, and we plan for that. The issue is that in the first couple of weeks, it's very hard to get the attention of an organization to actually do anything. It's, if you get 2, 3 failures, but they started a house fire, well, that gets everybody's attention. And then we go fix that problem. We deal with it. And it's usually all hands on deck, and we get lots of folks there. But if we get 1 or 2 issues, let's say a response time is a little bit sluggish, or a cable came loose, for example, and we find that, so we'll blame manufacturing, even though I know of plenty of cases where the cable design and the choice of connectors and so on were inadequate for the product. And it was very difficult to actually get the cable to stay connected, the connectors to remain latched during transportation. Yet we tend to then say, oh, that's a manufacturing issue. And we jump up and down and yell at them, get red in the face. Hopefully none of us here do that. And say they need to work harder, work better, work faster. Or it's a component. The vast majority of failure analysis, which I don't call true failure analysis, is we isolate the problem, we're able to reproduce it, and we get it to a component. Let's say it's a optocoupler. And the first thing we do is get the optocoupler team suppliers on the phone and tell them that they have a problem. We're shipping this out to them. We want a detailed failure analysis on the component, making the assumption, oftentimes unwarranted and not true at all, that they have better failure analysis capability than we do. We've been hammering suppliers for decades and decades to reduce costs. And in our own organizations, if we reduce costs, we don't, if we're cost conscious, we don't build a $10 million failure analysis lab, right? We might have a microscope. We might be able to do cross-sectioning. If you're really advanced, you might have a scanning acoustic microscope or an X-ray machine, or depending on your product, you may have a small chemical lab that deals with this stuff. Or in your development lab, you may have some fancy tools that you could do some failure analysis work with. Vast majority of organizations I've been into, though, is they isolate it to a component or a subassembly, send it to the vendor. And 9 times out of 10, you get a response late, weeks or months later, that basically says, well, it's not our fault in some form or fashion. And I had one client that, and I know anybody that's been in a number of these webinars have heard this story, but the general manager says, why are we in this meeting? I had done an assessment of their organization at the request of the quality director, and they were experiencing a 50% per year failure rate of their products, and they had a 2-year warranty. So on average, in general, they were making 2 free units to maintain a customer that bought their product, that bought 1 unit, and then they ended up with 3 brand new units in their system, in their ownership over the period of 2 years. And then after that, they just didn't buy their product anymore. The general manager said, why are we in this meeting? And it's about warranty and about field returns. He goes, well, customers always complain. That's what they do. That's just normal. And then I very quickly mentioned that it's costing you tens of millions of dollars a year, and you're losing market share. And in all of the downsides of having such a high failure rate of a product that really should work pretty simply. And then once it got into money, then he understood. Unfortunately for them, is they had set themselves up in a trap where they only counted warranty. The only thing they counted as a warranty cost not the replacement unit they got shipped out to them, the brand new unit they got shipped out to the customer. That that was part of production. They didn't count that as a warranty. They only counted the replacement components. So if a compressor failed on this unit and it was a $10 compressor, they counted that $10. None of the testing, none of the failure analysis, none of the rework, none of the new units going out, none of the any of that stuff. But anyway, I could talk about those guys all day. Maybe I'd do another podcast on them. Hopefully none of you are in that realm because you're conscientious, Zendo reliability type folks that pay attention to reliability and do good stuff. Yet many of you may know, and I won't ask how many of you run into this, yet it's common, way too common. Now, let's say I got a couple other comments here. Root cause, first 100 analyzed. Oh, I like that one. Heike, I think that's pronounced, or Hiki. No, Heike, I like that better. Anyway, logging them, tracking them, failure analysis, root cause analysis, and then assess the scope and effect of the problem across the population. Okay, I like that. Those are all good stuff to do. Another one is I run in, it's a little bit better than basically ignoring it, is you take a look at the field failures and you gather data and you do a Pareto plot of them and you say, oh, we've had 57 of these and 23 of these and 2 of these and 2 of these. And let's go look deeper at the one that has the most. By the time you get that many failures, you're weeks or months into it, depending on your particular situation. And the development teams dispersed, they're working on the next project, the manufacturing is locked in, you've ramped completely. And you will continue, even if you fix the biggest issue in the field, you probably already have a lot of units exposed to that particular failure mechanism still out there. So you're going to have this long tail unless you do a recall. Sometimes you're lucky and it's software and you can remotely update stuff, or you can ship a kit to the customer to swap out a component or a module or things like that. Sometimes we get lucky. Yet the Pareto analysis takes data. If you've only gotten 3 failures and they're all different, at that point, the thing I most commonly hear is, well, those are just one-offs. That's not a big deal. Now, if it was all 3 and they were exactly the same in the first week, it might raise some eyebrows. Yet if you're shipping a couple hundred units or a couple thousand units, it's still hard to get people's attention to take action on it unless it's a safety related thing. So the Pareto analysis is a common approach, yet it takes time, and it takes, you need data. You need enough data to actually do it. And it does require decent failure analysis. Tracking by the failure mode side is confounding, to use a design of experiments notion of that term, is that there's many causes for the same failure mode. So let's say your computer doesn't turn on. That could be all kinds of different things. So at the failure mode approach, you might get to where you're going to focus on what's causing that and then do a Pareto of the root causes of those things. I much prefer doing the root cause analysis and then taking a look at not only what can you do about it, but what's the Pareto, what's the prioritization for that. Keep in mind that Pareto analysis is a way to prioritize. And sometimes we add costs to it, and sometimes we add impact, or what's the likelihood of this being a more common problem, things like that. Yet it does still take time. It's a prioritization process when you have too many things to work on. Well, how do we get ahead of that game and avoid having to do a Pareto because we just end up with so few field failures that it's not worth putting it on such a chart? Well, that's what I want to talk about. One other way that I've seen organizations do this, and I didn't see anybody mention that, I'll take another quick look at it. A lot of failure analysis, a lot of analysts, little variations on that, logged and tracked, things like that. All good. Fracas Systems is a great tool is, let's say we set up a goal for our product. Let's say 98% over 1 year, 98% reliable over 1 year in our environment, for this functionality that this product should do. And then we maybe even have a system model that breaks it down. We've apportioned and modeled how reliable all of the subsystems are. And so we know that this one's got to be 99.5% reliable over 1 year and so on. And then we start gathering field data, and we get 1 or 2 pieces of data, and they're in different subsystems. Well, now we have 1 point of data, and what's the probability of getting a failure within 1 week, given that reliability goal and its expected distribution? Well, it's a finite number. Even though it's very, very small, it could happen. So we go, okay, well, it could have happened. So we can use statistics to kind of squint at it, go, well, that's not impossible. We got 1 or 2, and then you get 15, 20 failures. Now you got enough data. Hopefully they're all in the same similar failure mechanism, or in the same module, for example. And we can do a quick Weibull analysis and say, all right, well, this plot has a similar beta, yet the characteristic life seems to be less than what we expected. Or it's on a different beta, so we're getting more failures early on versus later on. And then depending on your failure analysis and what you do, you may give you some clues as to what you can do about it. Is it meeting your expectations? So imagine a Weibull plot for your system reliability goal. And here's the specific goals, but based on our internal modeling and assessments and work to understand if it was good enough or not. Here's what we expect. Here's a cumulative distribution plot, or a CDF, and here's our Weibull, what we expect. Now, if we get our first couple of failures and they're to the left of that line, they're occurring earlier and more frequently than we expected, well, that gives us some sensitivity that something's going wrong. And the more that we have, and the more we can plot out what's the actual field failure rate, we can still compare that to the goal and say, well, that's close enough. We're within our tolerance, we can deal with that. Or this is a signal that, yeah, we're 5-10% off, we're way off, or this is heading the wrong direction. This was totally unexpected. And we, in a failure mechanism maybe that we didn't know about, or our estimates for it were unrealistically optimistic, and so on. So it's a way, I see it in some organizations that say, well, we use field data analysis to compare to our system goals and models and the expected failure mechanisms to judge whether or not we're close enough, keep doing what we're doing, or, oh, we need to do something about that. So it's a little bit different than a Pareto. It's not just the most frequent. Yet it relies on a pretty robust reliability program that has goals and apportionment and system models and some expectation of what's likely to fail and on what distribution. So it takes a bit more work, but I've seen this in a few organizations, and it gives you a trigger saying, all right, we got to do something about this one. And it's similar to a prioritization method, it still takes a good amount of information, or understanding of statistics within the organization, and which is one of the major hurdles I see in too many organizations, is as soon as you say, I want to do a Weibull with a beta and an eta, eyes roll back in their heads, which is unfortunate. So hopefully you've trained your organizations to understand and deal with that. All right, so those are a couple of common ways. But some of these and some of what you've mentioned in the chat window deal with what makes a decision. So let's say it's a Friday afternoon, and I've had this happen more times than I can count, and you're just kind of wrapping up your desk and getting ready to head home, for a long weekend, hopefully. And the phone rings and says, "Hey, we just had this issue." And I get an email from a different division saying, "Oh, we just had this issue," and they're the same. It was an issue that I remember. It was cracking capacitors. And one of my voicemails that day was on that. It was, so the first one was like, "Oh, okay, I'll deal with that on Monday." But I get two more Friday afternoon on the same basic problem. It's like, Now, when I was working at HP, we had, at one point, Hewlett Packard, I was told, was using 1/3 of all of the suppliers' capacity for capacitors. We made all kinds of electronic components, and I think HP still does in their various forms they are today. And I went to my director and said, "Here's what I've experienced today. And this division has got this experience, this division." And she said, "Make that a priority." And later I was able to ask her, what sense was it that said we got to deal with that? And we sat down and talked about how she took this kind of cloud of information that I had gathered briefly from 3 different conversations. And she said, basically, the risk is that 10% of our capacitors are bad. That's going to affect millions of products. And so the potential downside is large enough that we need to deal with it at a corporate level. And so I was like, "Oh, okay. I didn't think about it that way." So what is it that you do that triggers that you're going to, call in the troops and let's dive in and solve this particular problem? Because root cause analysis and analyzing the first batch and logging stuff and doing stuff like that is a start. But at some point, something has to say, we need to fix this. What triggers that change from tracking to doing in your organization? Yeah. Percent of warranty cost to sales ratio. Yeah. If the warranty is too high, that's a good trigger. Um, Preset failure rate thresholds. Okay. Yeah. You just get too many failures. Good one, Mahindra. Good one, Kevin. Um, a demanding customer. I heard at one time is that the only time the production line gets shut down is when a major customer is complaining to a vice president of the organization or higher, and then we have to shut the line down. Otherwise, we always run it. Julie, yep, severity, the safety related stuff, I think is the easiest one to drive to get people's attention and let's just fix it. Unfortunately, we should be doing that during the development process. And then to some extent, that's harder to convince people, but that's it. Yeah. Jason and Julie, you're thinking alike. Yeah. Availability impact. Yeah. Yeah. And especially if you're in a supporting, say, a production line where they know how much cost per minute it cover, unexpected downtime is costing them. It becomes a pretty big financial reason to do it. Failure rate and safety. All right, good, good. Let's change some of the thinking about how to deal with field failures, especially the first ones you get back. All too often, even if we log it or do failure analysis or plot it or do everything else, is that failure that you receive, the first one you get back, say a week or a month within starting the shipment, is gold. It has a lot of information. That was the first thing that failed. So if, let's say you have 100 products and you have a 1% chance of a failure and you get a failure within the first week, that's a 1% problem. In most consumer products, that's not a good place to start with, especially if it's starting early. or 1 percentile type failure. But and it starts early. So if that failure mode just continues with some, say, Weibull distribution of some sort, we're going to expect more failures earlier than expected. Um, some organizations I know take a look at it and go, we don't expect our first failure at some, say, like the first percentile won't exist until 6 months from now. So we don't expect any failures hopefully for the first 3 months, if everything's going according to plan, and maybe just a few for the next 3 months. And then comparing that to what you actually get is a good thing to do, saying, is this something new or unexpected or unsafe or whatever? So this one organization I ran into, I was doing an assessment. Oops, I got to go over to the right screen, I guess. There we go. Is I ran into an organization, this is 20 some plus years ago now, that they were making workstations and they were losing market share because their products were just not reliable. And at that time, workstations were used by electrical and mechanical engineers for designing, for finite element analysis work, stuff like that. The normal desktop computers just weren't powerful enough to be a viable, good tool for them. So they used workstations, which, geez, the computer on my desk now kind of would blow away most workstations even back then. But they were they were like servers, yet designed to do CAD, for example, more readily than a server, which is moving information around, basically. So it had a slightly different purpose. They were expensive and they were fast and they were critical to a design team to get their work done. And so they were often sold, say a company had 20 engineers that needed workstations to do their work. So they would buy 20 and replace whatever they had before all at once. And the products were supported by a field technical team or field service team that would come out and help with the installation. This is how early in the computing world it was. And they would do all kinds of cool stuff, get them booted up, do initial training if it was necessary, all that kind of stuff. With all of that infrastructure in place and all that market they were building, they were losing market share. Other workstation vendors were creating products that were just more reliable. The issue is that it's like availability. If your computer is not available and you have a design you need to get the next stage done in the next couple of days, you can't wait for customer service to spend a week or 2 weeks to get you the repairs or a replacement. And that's why they were losing service. They failed more often than other competitors, and it took a while for things to get back into service. So one of the things this team did is they made their systems user-friendly for repairs. It was a big motherboard in a pizza box, basically. And so they put a great big door on the side of the pizza box, and the entire system could slide in and out. The motherboard would slide in and out and had one connector. So the customer could open the side door, open up, take off the one connector, pull out from the edge connector at the end of the chassis, and install a new one. And they would FedEx out a brand new motherboard as soon as there was a customer complaint. So that's one thing they did in order to tackle the unnecessary, excessive downtime they were experiencing. But they also did a handful of other things in order to design their product more reliably, did a bunch of cool stuff. And I've talked about this group and many other podcasts and webinars and so on. But one of the things that surprised me is what they called the Delta phase. They said, well, we do, prototype testing, we do beta testing, and we get some trusted customers to check it out and do a lot of other stuff. But now that we launched the product, we're going to call it the Delta phase. And so what they did is that every failure identified within I think it was the first 6 weeks or 8 weeks of the product launch, that they would fix it. It didn't matter if it was big or little, or it could be waved off or a one-time thing or whatever. There was a reason it failed. And it could be a design issue, it could be a manufacturing issue, it could be a supplier issue, it could be customer expectation issue, or it could be all kinds of things. But they did a lot of what you mentioned in the chat window about what your organization does, with one difference is they had a team from the development team. They took the lead or a senior or a very knowledgeable electrical engineer that helped design the core of, say, the motherboard, and another one that designed and worked on the ASIC set of chips that were used in the system. There was also a mechanical engineer. There was a computer interface type person, somebody working with the firmware and the GUI systems, and the various major elements of the system. And I think they had 6 or 8 people that were core with great knowledge about the product and its design that were deemed the Delta team. And I think there was not a sitcom, a TV show that was the Delta team at that time. So I think they stole the name from that. And their full-time job for the 6 weeks was to identify and resolve, permanently fix any failure that occurs. And wow, what an investment. You got, these are not your field techs. These are not your, a quality engineer that's part-time dealing with field failures. This is not send it to a vendor. This is not send it to a repair center and ship it back to them. Now, the way this product was sold is that this team would fly or travel to wherever the next installation was. And one of the things they had to do was teach these engineers how to work with customers and pay attention to let the customer work with the product and observe how they work with the system, what they expected from the system. And any hint of that's not right, or that took too long, or just subtle little variations from what was the customer's expectation. And if you've ever worked with engineers, and I imagine most of you are engineers, is that as soon as you see something not quite going as it should, you jump in and fix it without, oh, you need to push this button first, which is part training, which is fine. Yet that's not what they were there for. They were there to see what happens that causes what would eventually become a customer complaint or a field failure. And then they had a blanket purchase order, a good sized blanket purchase order with a local third-party failure analysis center. It was they had all the great equipment. They had a bunch of great technicians and engineers that really were good at working with electronics and so on. And so what they did is anytime they got a board back or got an issue that they were trying to resolve, what exactly was what was the issue, they went straight to the lab, to this organization that could do detailed failure analysis. The engineers would work with them through on the schematics and what it should be doing. Here's a good working system. Here's what this one's doing. They brought spare parts and so on. And then if they got it isolated to a part or to an area, then it was this failure analysis lab had all this non-destructive imaging systems and failure analysis stuff. And they had all the destructive ones too. And then within a day or two, they could get to the root cause from a physics or chemistry point of view very, very quickly. So imagine the amount of expense that an organization is doing, say, taking their core engineering talent offline from doing their day job of designing products to doing failure analysis and fixing it and saying, or here's the design change, here's the manufacturing change, here's the vendor change, here's the component change. And they were fast-tracked to do all of those things. Now, the expectation part for this team was do not ignore any failure mechanism, any failure complaint. And sometimes they got involved with, orders being wrong. They were expecting so much memory installed and it didn't show up that way. And so they got a hold of the folks dealing with orders and interpreting it and packaging products and shipping it to this particular customer to see where the errors were, where the mistakes were, where the hiccups were, and help solve some of those problems. Primarily, they were there to focus on mechanical and electrical problems. Yet it was an amazing investment to make it work. And you might be wondering, why in the world would they do this? We ship all these products. We can't afford to take offline, a good segment of our development team. Well, to double down on it is what they did is they funded this program. This is what their full-time job was. They had travel budget. They had failure analysis budget with this lab. They had fast track ability to say halt production, to change out components, to change designs, and so on. They had the power to make changes within days that in many organizations may take a month or more. Now, it's risky to make a change and not really know if it's going to work or not. Now, part of the setup for what made this work for them is they didn't build 1 million units and then put them on shelves in retail stores, right? They were shipping 20, and then in another next week they shipped 30, and the next week they shipped 15. A big order might be 50. And so the production didn't ramp up to its full capacity right away. And it rarely ever did. They wanted to find out, there's no reason to build 100 of these units when we're only selling 20. So the ramp followed. They had plenty of capacity. They could ramp faster if they needed to. And eventually they did. The word got out their products were markedly different, and they ended up having to get more manufacturing capacity. Yet they didn't have to go through 3 levels of approvals and make recommendations to be ignored later and so on. They had like ultimate power to make changes with this design, with this product, and just make it work. The risk was that they make a mistake. And so they also then very carefully tracked all of this stuff, much like an 8D process, to see whether it really worked or not. And then if it didn't, if there's any indication it wasn't working, then they go back to that and dive deep into it again and figure out what they did wrong and improve it. So the team was empowered. There's no doubt about it. The results, their emphasis was to get results quickly. And if they had to do, if there's any unknowns or any, we're not sure if this is really the fix or not, they would set up as quick as possible tests they did. And oftentimes they were with customers, going back to like a beta program with a customer saying, all right, we've got these 3 options here for seeing it. Can we run this with you guys for a couple of weeks and see if it works? And customers were ecstatic about it because they now had more capacity, more workstations, but they also knew that this organization was taking their initial field failure problem very seriously and were working very closely with them to solve it. And so it gave them the capability and credibility to do something about it. Now, one story about this was they had field representatives that basically were working with clients or customers to do the installations and boot up of these systems. One of their very first trips was to a European organization that had bought, 15, 20 units. And the field rep was, helping with the unboxing. They were getting all these systems set up and booted up. And one of them, the first one, the power supply just popped and smoked, basically. It just failed immediately. And so the field rep pulled out that power supply and took the unit that they were decommissioning took that power supply and stuck it in the new unit, plugged it in, and it worked. And so he impromptu identified, well, that part's bad. We're decommissioning this old one. Let's use that one to get you up and running. The field reps were trained to get the customer up and running. And at the end of the day, they're debriefing this rep going, why did you do that? And goes, well, my job is to help them get installed and up and running. If I have to come back tomorrow or in 2 weeks with a new component, I would have never, that's not part of what I'm supposed to do. And then they said, well, what happens? Would you have reported that issue? And he goes, oh, probably not. I forgot all about it until you mentioned it. And they were sitting at dinner. And if that 15 units all got field fixed, the next unit to Europe would have failed, because what they turned out, the electric engineer opened the box and go, with one quick look, said, we forgot to make this compatible with 220 volts, with the 20 amp 220 volts or whatever the power was that was common in Europe. So all of their units in Europe would have failed. And hopefully they had a field rep that knew how to do this quick swap and had decommissioning units. That single identification that took less than a day saved them millions. And so they were on the phone that night, stop production. Here's the change they need to do, the power supply. That was available the next day. I think I spelled field wrong. Looks like field. Maybe it did. Anyway. And that single event of the 20 or 30 that they actually worked on in detail and made pretty dramatic changes paid for that program. At the end of the day, they were able to drive down the early field failures to less than a tenth of what they normally would see. And even with a good product, with one of their better products from years prior. And they did it much, much faster. So they didn't wait for Pareto analysis. They didn't wait for something to be a major issue or a major customer. They didn't work through all the bureaucracy. And so not only did they cut their field failure rate dramatically, they did it much, much faster. And customer satisfaction went up, all kinds of things happened. And so they institutionalized that, to make a long story shorter, I should say. They institutionalized that program so that every time they did a launch, they had a team that tracked it. Sometimes it was 4 weeks, sometimes it was 8 weeks, depending on the nature of that particular launch and product. And their market share just dramatically over the next couple of years just dramatically went up, because their products were head and shoulders better than anything else on the market. Plus, customers got the impression, rightfully so, that if you call them and say, hey, it's not working, they were going to do something about it. And then after this team's work was done, there were very, very few other failures. They got rid of the things they missed during the development process. And the development process had made significant improvements also. So there just weren't as many potential failures, yet they still occurred. And they learned a tremendous amount about it, including that team. They learned how customers really use their products and what kind of environmental things to keep in mind, to on and on and on. They came back to the development process so much more interested in design for reliability than the team members that didn't get on it. Over time, that became a competitive action or activity within the organization to be nominated to be on that Delta team. So it was motivating, it was educational, it was financially very rewarding for the organization and all of the people involved in it. So that's what I first learned about the Delta program. And of course, then I mentioned this in a webinar 20 plus years ago. And the first question I got was, well, what happens if we're in high volume? And so let me talk about that for a moment here. Let me take a look at the comments here. Yeah, Brian's talking about the field technicians focus on helping the customer, which is good. I agree. It is very good. And then not reporting it or reporting it late or in an ambiguous way or whatever. And they're not paid to report problems. They're paid to fix problems and get customers back up to speed. Yeah. And so having 6 engineers in the back of the room while the field tech's doing their job at first was pretty intimidating to the tech. He's being watched. And the engineers were coached not to interfere, let the process unfold like it should. Because these folks had all been through all of the bench testing and all of the product testing and stuff like that. They knew how to handle their product to get it to do what it was supposed to do. The customers and field techs didn't as well as the engineers did. So let them deal with it and generate the failures and watch and observe. If there's a confirmed failure, then start the failure analysis process. And so that was a difficult thing. One of the leaders of that program that was one of the most difficult things, was to get engineers to stay hands off until it was ready to be taken over for failure analysis, is to gather information about what happened. How did this failure manifest itself? So what about high volume? I know some of you might be in high volume situations where you build a whole bunch of products and you send them out for the, some phase of the year when you have a bunch of sales, or it's overseas manufacturing where you build a bunch and fill the boat, bring it back and distribute it. Or you go to retail centers where you're doing a product launch and it has to be in all of the big box stores at the same time. We don't have that luxury of identifying the failure and then fixing it while it's still in our hands, while still hasn't been manufactured yet. So how do you deal with that? And the other variable of that is like these workstations, they were built and they would be sold for a year or 2 years with minor modifications, but for a couple of years. So they had, and then equipment, factory equipment, excuse me, factory equipment is often, 5, 10, 15 years, something like that, lifetimes on it. Very low volumes, yet it's made to work. It suits the way the Delta team came, the Delta phase is envisioned and worked. But what about high volume, where we don't have that luxury of a small set of units, and we have opportunity to avoid future problems because they haven't been built yet? Well, the same basic tenets apply: is get the right team, get the people that really, really know this product inside and out and understand what should be failing, what shouldn't be failing, and understand and can identify the failure mechanisms quickly. They know they know the way around a oscilloscope. They know their way. Do people still use oscilloscopes? Maybe I'm dating myself. They know the circuit and they know what voltages should be at certain places. They know what kind of performance they're looking for out of it, and so on and so on. Thanks, Max. I'm not that old then. There's probably really good scopes these days, but here the expectations change to include more of the entire organization. You still need a good design for reliability. Your best approach to avoiding field failures is create a reliable product. The other part is that the quality, reliability, and the call centers are typically the front line on high volume field failures. Let them know, and some organizations even have, what are they called? Not compliance. It's a group of engineers that after product launch basically do what this Delta team was doing, but I'm drawing a complete blank on what a couple different teams they call it. Of course, there's different names for them, but they basically run interference so the development team doesn't have to get involved with the field failures. And I'm like, well, that sounds crazy. Why don't we really make a product that doesn't fail. And if it does fail, yeah, goes back to the development team so they can figure out what they did wrong. But there's all these organizations, parts of an organization that's their current work. So if we create a new team from the development team, from the engineering team, the design and development team, I should say, it's kind of taken away some of the work and functions of these other parts of the organization. And so some negotiations, some setting expectations, some working together helps to make that work. The other part is management, is getting it installed in an organization takes that big investment and leap of faith that it's going to pay off. And if it's a time to market is the primary focus and everything else, well, this isn't part of time to market. So it's really hard to justify it based on that. One of the best arguments is that what I found anyway, is that if your development team is doing the support for resolving field failures, many design teams end up with 20 to 30% of their engineering time is spent on previous iterations of their product, previous launches, and not on the new product. And that goes for the 6 months or a year. And so one of the benefits is that by focusing on it early and hard, solely focused on it with this Delta team kind of approach, is that it frees up more of your engineering time over time. And there's some evidence to that. Of course, it's all locked into these different organizations I have non-disclosure agreements with. But the idea is that if we spend 6 weeks really focusing on resolving every issue, then we won't see those issues over time. They won't bubble up in different Pareto analysis and so on. That's a hard sell when time to market is the key thing, until you've done it once or twice. It's sort of like if you don't know anything about HALT, H-A-L-T, it's hard to convince some teams that breaking it on purpose is useful, but that's a subject for another webinar. The key part of this, though, by far, is train the call centers. Call centers oftentimes have scripts that say, all right, if a customer complains about it's not booting up correctly, then there's a handful of questions, and here's some things you can try to do to fix that. Or, I turned it on and there was a pop sound and the smoke came out of the back of it. Well, many call centers go, that's a problem. We need to get the unit back. Here, we'll get you a new unit out right away. Take it, they deal with it in a variety of different ways, but they often have scripts. So you need to get a hold of those scripts and change them so that you get a bit better parsing of what the failure modes are. And with the idea that, like that smoking power supply, yeah, we want that back. We want the whole unit back, and as fast as possible. And the idea is, I think one person mentioned they get the first 100 calls, they go right after those, or first 100 failures, they go right after. That's the idea, is alter the script so that you identify hard failures, whether it's software or hardware, and get the entire unit back and get as much information about how it's used, how often it's used, can it be replicated, things like that, which goes into a different track than most call centers go into. And do that for a limited time, say a month or so, and then remove those scripts and so go back to the more normal operation or whatever time frame is appropriate. But the idea is to get more full units back, even if it's an inexpensive unit that you would normally say just throw it away. Pay for it to get back. And then that lands on the desk of this team. So instead of them traveling around the world to watch installations, they get more field returns. They get a bench full of products that aren't working. They can do the bench diagnostics. They can do the failure analysis, teardowns, all of that work, make changes to design, manufacturing, and suppliers. The idea is get the units so that you have something to work on and get as much information from your customers as you possibly can. And that starts with that call center. And the idea is to send the call centers and build in those scripts. Here's the things, and here's how customers might talk about what we expect to fail. These are things that are on the margin. These things are the things that we just don't know whether we've solved it or not. And that takes a pretty mature development team to say, here's the areas that are most likely to fail. And here's the descriptions you might get. And then the second part is training the call center teams to go, we weren't expecting that. Ship the unit back. I'll ship you a new unit out immediately. The idea is that that's your first touch with this problem. And identifying, is it a quick fix and it's maybe some customer training, which the call centers can do. They're off and running. That's fine. There's nothing wrong with the product. It's except that our instructions or expectations or customer use is off. But the idea is that get those units back, do the detailed failure analysis, and make the changes. So if we've made, say, 100,000 units at initial launch, and we expect to make another 900,000 over the next couple of months, the sooner we get those failures resolved, built into the next set of manufacturing, the fewer of those potential failures we're going to have in the future. Same logic applies. If you solve the problems, they're not going to show up later. Don't worry about whether this is a big problem or a small problem. Solve every problem you possibly can. And so the gist of this is a bit different than which ones are safety or important or likely to go all over. Lots of analysis, lots of hand wringing. Just solve them for the first month or 2 months. If you have a problem, fix it, solve it. And that takes an investment. There's no doubt about it. So, and I think I got most of this talked about. Getting stuff back. Yeah, all that we talked about. So final question for you all. We got a few seconds left on the hour. Would this work in your organization? What are the barriers you see? Yeah, Bill, I agree. Lessons learned makes a lot of sense. I don't agree with the database idea. All right, you get a new engineer and you say, hey, go look at the database. Well, you won't see them for a couple of days. They might learn a few things, but yeah, it needs to be curated and narrowed down. Thank you, Patricia. You're welcome. Thanks, Ajit. You're probably already gone. All right, so will this work in your organization? Yeah, it needs to be customized. I agree. Every product, every scenario is different, yet a few basic principles here is fix every issue you find early on. Yeah, really dedicate. It is an investment. There's no doubt about it. And so you need to find the right champions to help you make that work. Yeah, some products are too expensive to fix for insignificant gain. Yeah, there's a risk of that. Well, let's say you have a field problem, right? Say a cracked capacitor. That could be a one-off. And if you go investigate it and fix the board flex or whatever was the cause of that particular capacitor failure, it may not exist on any other product. Now, you still get the value of that team understanding that capacitors crack and we need to deal with that. On the other hand, is that maybe there's a depaneling, this is a real life story, a depaneling station that is cracking capacitors to the extent of, say, 50 to 70% of your products. Do you want to wait until you get 50% field failures, or do you want to fix it before you get that many products out there exposed that have that mechanism, that crack already initiated? And it's a risk topic. As my good friend Greg Hutchins would say, everything's risk. But it's, if you take time to sort out which ones to go work on, you've just built another 1,000 units that have the built-in potential problem in them. So let's just fix it and cut the everything else. It's an investment. Let's say only half of the fixes actually make a significant difference to the failure rate. By saving time, by not sorting out which half to do it, we get to fix a whole lot of issues. All right, thanks, Brian. I'll let Greg know next time I talk to him. And there are some that are very expensive. Let's say the ASIC has an inherent design flaw in it. At that point, because it may take months before you get a new ASIC available, but by knowing that sooner than later, you can start that process. You also work with, what's the workaround? How do we deal with this thing? I think knowing sooner than later is a key piece of this. Yes, and some fixes do take an amazing amount of work and so on. Yet it's one of those things where until you actually dive into it and try to solve it, you don't know. By illustrating the focus on fast tracking and identifying and solving problems as quick as possible think of it as a sprint in an agile process. Is we're going to sprint on this for a couple of weeks or a month and get as much out of it as we can. In my experience, in the dozen or so organizations I've saw implement this, it works. And unfortunately, it's not something I can write a paper on and so on. But it's one to think through. Maybe you can implement bits and pieces of this thing. But the idea is that identifying failures and fixing the process that's causing that failure to occur is an extension of what we do in design for reliability. And it helps us reinforce the concept of designing a reliable product and reducing our field failure rate. Even if you have a good field failure rate already, it doesn't hurt to improve your customer satisfaction and brand loyalty and those kinds of things. Our competitors aren't standing still and working on ways to take part of that market share. Yeah, Bill, you're exactly right. Is the wrong supplier for your PCA manufacturing. There's so many things that can occur in building a circuit board that will be latent defect. Cracked capacitors is a classic one. There's so many other things that can happen. And that really does take understanding your supplier, understanding the soldering process, the manufacturing process, pick and place equipment, and so on. I had the great fortune to work on a product line that we had our own production plant basically in the building. And we did a small amount of production, but it was mostly used for prototyping. So I got to be very comfortable with the manufacturing process so that when I worked with suppliers, these contract manufacturers to make our units, I really knew what they're doing and talking about. And when we did assessments, we could really dive deep into it with some pretty good knowledge about how it should work and what we were looking for. Way too often is we've disassociated ourselves from how circuit boards are made. So it's very difficult to walk into a factory that, let's say they're making fiber optic cables, and you've never worked with polymers before, you've never worked with glass before, you've never worked with cabling before. How would you start that assessment? How would you understand what you should or shouldn't be working with? You might get a good lunch that's always worth the trip, but you do need some detailed knowledge to really understand how your suppliers work, which isn't always easy to get if you don't have a manufacturing facility that you can spend a lot of time on. All right. There are barriers. There's no doubt about it. So I'd love to hear what you think of it, what kind of barriers or options or ideas you have to improve it or implement it in your place. And it may be well worth another webinar to go into, well, how do you actually do this? And what are some of the common barriers you say? That might be an interesting topic, if nothing else, for a podcast. So anyway, thanks so much for today and for all of the input and feedback and so on so far. And I look forward to our next webinar in about a month. Chris Jackson's last one for the year is in 2 weeks, and then he'll be back in January. But hopefully it all works for you. Have a great rest of your day. Happy Tuesday.